I'm Kendra Little, and this talk is about updating statistics in SQL Server. When should you be doing maintenance to update stats? And also, what do you need to look out for? This talk is about a topic that really confused me for quite a few years. When I first learned about stats, I thought it was the answer to all my problems to update the stats, but as I worked with SQL Server over the years, I learned that sometimes I caused more problems or didn't completely fix the problem and just gave myself a new problem. Before I ever got into SQL Server, I studied philosophy. And when I studied philosophy, I always found studying Aristotle to be a little bit irritating. And it's because he always talked about not being too extreme, not doing too much of something and then not doing too little of something, always taking this sort of moderate middle approach. And my problem with stats over the years is that I never took a moderate approach. I always wanted to do way too much of updating stats or way too little. And what I'm going to describe here is the pitfalls and the problems that I ran into over the years. Now, updating statistics has helped me solve some really real problems. I first learned about statistics in SQL Server because we were having a really big performance problem. I managed a system with other DBAs where we had these report servers that would periodically pull a lot of data from fact and dimension publishers. These fact and dimension systems would calculate all sorts of fact data and dimension data, and then the report servers would go out, and the report server would go do a call and say, hey, do you have data that's fresher since the last time I pulled? And if so, I'll go ahead and take it for a bunch of tables, and I'll update my tables. These jobs used link servers, and usually they were pretty fast. Fast being 15 minutes to 45 minutes, because they're actually pulling over considerable amount of data. But sometimes these jobs would take 2 hours, 3 hours, 4 hours. And we had a monitoring system. I mean, this data had to be fresh. So we had a monitoring system that would look at how long have these jobs been running and then engage the person on call if they'd been running too long. And this started happening more and more. And it wasn't that the job was failing, it's just that it was really, really slow. Now, I learned about statistics as part of this because I'm like, well, why is it slow sometimes and not slow other times? It doesn't seem like we're actually pulling over that much more data. We had a problem where the server that's pulling the data over the link server was sometimes getting a bad query plan. And this was due to a statistics problem. We had millions of rows in these tables, but on the publisher, sometimes a bunch of data would change, but the amount of data that was changing was less than 20% of the rows in the table. And if you've got 10 million, 50 million, 100 million rows in the table, you can change an awful lot of rows without changing 20% of those rows. So if I'm going over and I'm saying, hey, it's 6 a.m. now. I last pulled data at 4 a.m. How many rows have changed since 4 a.m.? If statistics haven't updated on that column that I'm looking at for, the last update column, if statistics last updated at midnight, it's going to say, oh, well, maybe 1 row. If actually it's 2.5 million rows, if I've estimated I'm going to pull over 1 row and I'm actually pulling over 2.5 million rows, in a complex SQL statement that uses sorts and joins and all of this other stuff to figure out the right data to pull from a bunch of tables, and I get a query plan that's designed for a little tiny amount of work, and then I'm going to execute it millions and millions of times, that can be really, really slow. The way that we solved this problem was on the publishing servers, on the side where the fact and dimension servers, we said, okay, whenever you finish your jobs that, add new facts in or add new dimensions in, at the end of that job, update statistics on the table so that whoever comes in, particularly on that last updated column on every single table, so that anybody who comes in and says, hey, I last picked up data at 4 a.m. If anything has changed since 4 a.m., the statistics have also been updated since then, and they can get a quality execution plan. Now because we're using link servers, there's even more to the story than this that has to do with weirdness about security and link servers. At the end of this presentation, I've got a link to a blog post that has tons of details on statistics and different things, including link servers, so you can use that link to dig in there. So I basically learned, hey, if you've got a slow query, updating statistics on the table that it's running against and then rerunning the query can sometimes give you a better plan. So I started using this trick. Maybe using this trick too much. Slow query against the OLTP server. What tables does the query use? Maybe I'll just update stats against those tables. This approach turns out to have some problems. So if I just say, okay, the query's slow, I'm going to update stats against the table. First of all, if the query is still running, updating stats to a running query does nothing. Statistics are only used before the query ever starts executing when it's being optimized, right? But then also, let's say I update stats and the next run of the query is faster than the first one was. Well, okay, well maybe I made it faster. I can't really prove it, but like also how do I know it's not going to happen again tomorrow or the next day or the next day? But then what if the next run of the query isn't faster? Well, if the next run of the query isn't faster, I've got another problem too, because when I updated statistics, I may have forced a recompile for the query. So the next run of the query, if it's slow, okay, is it if I didn't capture the execution plan for the first one, is it the same slow execution plan? Is it different? By updating statistics, I am changing things. So I never want to just go in. What I learned by doing this wrong is that you need to really figure out and grab that execution plan that is for the slow query and make sure you have all the information you need before you start like taking your golden hammer and, bashing things, because you are changing things every time you update stats. Around this time too, my team was also experimenting with creating statistics. We experimented with creating multi-column statistics that would help describe the data distribution for multiple columns. Now they're a little bit limited, and we actually didn't have any big performance wins by creating multi-column stats. It's not impossible, but it is kind of rare. And over time I kind of learned, hey, why isn't creating multi-column stats kind of a slam dunk more often? Well, when it comes to performance, creating indexes is incredibly important for performance. And when you create a multi-column index, it creates a multi-column statistic to go with it. No choice, it just happens whether you want it or not. So for your most important combination of columns, if you are indexing smartly for them, you are already taking care of the most important multi-column statistics as well. So you don't generally have to think about multi-column stats as a separate step as long as you're doing the indexes. And statistics also don't substitute for indexes. Statistics help the optimizer estimate how to do a good plan. Indexes are actually a way that it can avoid scanning a lot of data. Indexes are a way to seek to the specific data that you need and actually be more efficient, because indexes are a copy of the data. They are a data structure themselves, whereas statistics are more of a description of the distribution of data, right? Now, we did have great success, and I want to give props. I think it was a fellow named Dev Nambi. Dev's a really smart guy. He's active in the SQL Server community, and I used to have the privilege of working with him long ago. I think it was his idea. At one point, we had these servers where we were using log shipping. This was prior to SQL Server 2012. And the log shipping primary server, it just would get data from all sorts of places. And then read-only log shipping secondary servers were actually used for queries by customers. But on a read-only database, SQL Server can't automatically create statistics. A database has to be writable for auto-create statistics to work. Even if that setting is enabled, the database has to be writable for it to create the stats in that database. So what we did is a script was run to create a bunch of single column stats on the publishing server because user queries never ran against the log shipping publisher. It didn't have the chance to auto create stats for them. So you manually kind of created these individual column stats, and then they were restored with log shipping to the report servers, solved a bunch of performance problems, and helped SQL Server optimize queries on those reporting servers. Now these days, if you are running SQL Server 2012 or higher, you've got a lot more choices. So first of all, you could use availability groups instead of log shipping for something like this. Availability groups readable secondaries are also read-only. So they added this cool feature in where it can create temporary statistics in TempDB when a database is read-only, so that you don't have to go manually creating all of these statistics on your availability group primary or your log shipping, I always forget if it's primary or publisher, but any read-only database essentially can have these stats auto-created in TempDB just right out of the box, even in standard edition. So very, very cool. So we had to do this manually creating stats, but you don't always have to do it if you're using SQL Server 2012 and higher. Now I did learn that if you ever manually create stats using the create statistics command, you should be aware to treat that as a real change, because if the statistics don't improve performance, which is the only reason you would ever create them, you should go ahead and drop them, because statistics, any columns that they are dependent on, if you have a user created statistic on that, you will have to drop the statistic before you can alter that column. So if you just go out and create a bunch of stats on the production database server and then you leave them there, they could break a code release in the future. So you only want to manually create stats and leave them around if you've got a really good reason to, and you want to make sure that they are checked into the code base, and that including information on what queries they are helping, so that if people are going to alter the schema, they know, hey, we have to include dropping the statistics in this change. Other pitfalls that I ran into. Well, I started updating statistics too much. My whole team had solved a lot of problems with statistics updates, and we ended up with jobs updating statistics throughout the day. We had tables that had hundreds of millions of rows, and tables, the clustered index would be maybe 100 gigs, 200 gigs or more. Updating statistics with full scan, in other words, look at every row to update the stats against this table, it was taking many hours to run throughout the day. Full scan was being used because a couple of little situations had been encountered where updating statistics with the default sampling hadn't solved it. So we had these jobs that would do update table, the statistics on the table with full scan. Now there's a problem with update with full scan at the table level. And this is just actually a problem with statistics update at the table level. If you tell SQL Server to update all the statistics on the table, and let's say I have 10 columns on the table, and I don't have any non-clustered indexes on the table, it will treat each of those statistics updates as an individual item. So for all 10 columns, it will scan the table, update the stats, scan the table, update the stats, over and over and over. And this kind of makes sense, because if I just scanned the table once and then updated all 10 stats, well, wait, how long is it going to take me to scan the table? And how much data may have changed between now and when I got to the 10th stat? What if my table has 100 columns or 200 columns? So if you are just getting into updating stats with full scan against the table, the bigger your table gets, the longer this process gets, and the more and more you're going to be scanning. And the longer this job starts taking, you start running into issues where you're like, okay, well, I've got a performance problem. The job is running. It's been running for an hour. Should I stop it now and restart it? Is the performance problem related to this job at all? oh, okay, somebody needs to create an index now and it's going to block against the stats job. You get into all these, you don't want to be doing this maintenance if you don't know exactly what it fixes. What you really want is to not have to do the maintenance at all. But if you do have to do the maintenance, if you do have to do periodic update stats throughout the day, you want to make it really targeted to only these statistics that you know you need, ideally using default sampling, only using a full scan sampling if you absolutely have to, because it's so easy for it to get out of control over time. I've even found long statistics running against updates, running against tiny databases. I found a database that was like, I think it was 8 to 10 gigs. A job that rebuilt all the indexes, the job didn't even look at fragmentation. It just blew through and rebuilt them all. That took like 15 minutes. Updating the stats took 2 to 3 hours because it was scanning every table again and again and again. And this was because update statistics against the small database had been set up with a maintenance plan, using the update statistics task in the maintenance plan. The update statistics task in the maintenance plan it's almost featureless. It gives you the default of using full scan against everything, and the only other option is to use a fixed sample rate. It does not give you the option to use a default sample, because ideally, the default sample that is available to you in T-SQL update statistics, it says, hey, if you're a tiny table, if this table has like 2 pages, I'll go ahead and scan the whole thing. If the table is 100 gigs, I'll just take a little sampling. You can't even do that in the update statistics task and maintenance plans. You only have bad choices in there. So do not use maintenance plans for statistics updates, because it'll just take hours. After all of these experiences of finding all this stuff, I finally realized updating statistics is always essentially a reactive thing to a problem that is already happening. You are not preventing the problem from happening, and that's why this solution is rarely very happy for users or managers. You can't declare victory if the problem may come back and you're just kind of making it more temporary. So after I realized this, I became very conservative. I became hesitant to recommend, newer things that came out. Traceflag 2371 came out in SQL Server 2008 R2 SP1. It was announced on the SAP Teams blog, the part of SQL Server that supports SAP. And so you can kind of imagine that they were very, very interested in the fix. And eventually a KB came out that sort of describes it as essentially, supported by Microsoft. But if you think about how SAP runs on SQL Server, these tables tend to have many, many millions of rows. And you can kind of guess by the fact that they announced it, hey, this out-of-date statistics must have been a big pain point for them. Because what this trace flag does, when you enable it, it says, hey, instead of just using this 20% threshold for when stats are invalid, I am going to dynamically, starting at about 25,000 rows, this threshold will start getting smaller and smaller. The more rows a table has, the more frequently we'll say stats are invalid, and if you're going to use it, we'll auto-update them if they're going to be used in execution plans. This trace flag impacts the whole instance. You don't just turn it on for an individual database. So you have to be a little hesitant about it. And there's also like the KB that came out on this doesn't just say, hey, sure, turn it on. It says you don't need to turn it on if you haven't had performance problems due to out-of-date stats. But you should probably turn it on if you're running SAP, because we're really want you to turn this on. Now, these days, this trace flag is seriously going mainstream. And if you think about it, SAP is a pretty good testbed use case, SQL SAP running on SQL Server, but other people have been using it as well. In SQL Server 2016, this trace flag, the behavior that it enables is just the default behavior. The threshold for updating statistics becomes dynamic the more and more rows you have above 25,000. So this is really awesome. and is actually pretty encouraging in terms of if you do want to turn on the trace flag at a lower version, the fact that this behavior is becoming the default in 2016 should be a vote of confidence for your change approver that, hey, this is a pretty good idea if you struggle with execution plan quality due to estimates. These days I have come around to where Aristotle is, and I'm a little more moderate. I think you should be a little bit proactive when it comes to statistics maintenance, but you should, try to not become too extreme with updating stats all the time, because just updating stats all the time is still so reactive, and you're just going to be frustrated and always chasing a problem rather than preventing the problem from showing up. So there's two parts really to this moderate approach. Do you have a little bit of proactive maintenance, a nightly or a weekly statistics maintenance job? Look at how often you're currently doing index maintenance and integrate the statistics maintenance with the index maintenance. And I'll talk a little more about how to do that. If you come up with situations that make you want to update statistics more frequently, where you're like, oh man, I think we need to update statistics for this column throughout the day because we have this query where sometimes it gets a bad estimate and it's just slow. If you get into that situation, before you start updating stats throughout the day, look at, can I stabilize the execution plan in a different way for this problem query? Can I create or change an index so that it's always going to choose a specific plan and not get this slow plan? Can I change the query around a little bit? Rewrite the T-SQL? Or can I in some way freeze the plan? Perhaps using a query or a table hint. Perhaps using, in 2016 you can freeze a plan with the new query store. Prior to that you have to use a plan guide. But is there a way I can get around this proactively by saying, I don't want the bad plan to ever show up again? That is always preferable than this sort of reactive try to fix it if it gets bad. In terms of how to do the stats maintenance, start with a SQL agent job. You can use a maintenance plan as long as you're not using that update statistics task. If you're having it run a stored procedure, for example, that's fine. But most of the free third-party solutions out there, and I do recommend buying a third-party solution. This is just too much. It's so much work to write yourself. It takes weeks. Use someone else's free tools. Ola Hallengren has very widely used free index and statistics maintenance. There's also a free version of Minion Reindex. Test drive those, see what you like, see what fits you. What you want is for your index maintenance and your stats maintenance to be friendly and integrated, because when you rebuild an index, when you either create or rebuild an index, it is created or rebuilt with perfect stats, because it has to look at the whole index to do this new build. So it's essentially, it does a beautiful stats update with full scan. You don't want to be also updating the stats after that with a sampling, right? But then if you're doing an index reorganize in your script, you do want to follow that with the stats update, because reorganize doesn't impact the statistics. So you want to use a third-party tool that's already smart about this so that you don't have to go in and do the wacky math, but you basically want it to do a lightweight stats update integrated with your index maintenance. You might want to also add in statistics updates for any processes you have that update big batches of data. So if you've got something that comes in and inserts a bunch of rows or updates and deletes a bunch of rows, at the end of that you may want to have it update statistics on those tables if they've got a significant amount of rows, because if less than 20% plus 500 is changed prior to SQL Server 2016, it won't automatically update those for you. Now, if your job is essentially, at the end of the job, is already creating indexes or rebuilding indexes, the same thing I said before, create and rebuild has perfect stats. So you don't have to update statistics where an index has just been created or rebuilt. If you run into performance problems, and this is going to happen, make sure that you are capturing the execution plan of the query before you do something like update stats. You can do this using Atom Mechanics free tool SP who is active with @getPlans=1. If the query is currently running, you can do that. You can open the plan and save it. You want to know, hey, what plan was the slow plan and what parameters was it compiled with? That will be part of the plan before you go going around and like whacking those stats and updating them for it. You can also use a third-party monitoring tool or 2016's Query Store to look at, hey, what plans are running against the server and what plan was it using when it was slow. Don't just start updating stats and causing recompiles and then not knowing, hey, I don't know what the plan was when it was slow. Do consider using traceflag 2371 if you have millions of rows in your table and you think, hey, yeah, I've documented that we have some issues with updating stats. This isn't just a batch job where we can update, stats at the end of the load. We want these to automatically update more frequently. No, it is gonna impact your whole instance. You can't just do it for a database. And I list out the pros and cons of using this trace flag at littlekendra.com/recommend/stats. I've got a big blog post with information on settings to create statistics in SQL Server. What are the database settings that impact whether it will auto-create, auto-update? What is asynchronous stats update and what are the pros and cons to turning it on? What are statistics on temporary tables and when might you need to update those? I go through all of those questions and I've got links to other resources and free videos out there so that you can learn more and more about how you can manage updating statistics without having it make your database server weighed down, and how you can be the right amount proactive about statistics in SQL Server. Thanks for joining me today.